last lesson of Unit 8. So 8.8, solving exponential equations using logarithms. So we're going to see real quick what I mean by that. First off, make sure you're still able to solve for the variable using logarithmic properties and then switching it into exponential form. So we have two problems on bell work I would like for you to do by yourself, so go ahead and pause the video and then come back and check with me. I will solve them out, but please try and make sure you're able to do them by yourself. So this first one, number 1, we see that ln of x plus ln of 4 equals 2. So our first thing is we need to combine them using our properties. This is the product rule, meaning that we're going to get ln of x times 4, which is the same thing as 4x, equal to 2. Since we are now have one logarithm, we need to isolate it. It's already isolated for us, so we need to transform it into exponential. So again, no base here means we have a base of e squared equals 4x. To get x by itself, we divide by 4. So we're going to get x equals e squared divided by 4 when you plug into your calculator is approximately 1.85. Again, please make sure you're able to do these by yourself. Number 2, again, we've got two logs, log 9 of x plus 6 minus log 9 of x equals 2. So that minus sign means we have the quotient rule, meaning x plus 6 divided by x. So we're going to bring this into one log of log 9 x plus 6 divided by x equals 2. We don't need to isolate it. Please do not attempt to simplify that. It does not work that way, and we're just going to transform this now into an exponential function. So we have a base of 9, and it's going to be squared, equal to x plus 6 divided by x. I can now start solving for x. So I'm going to simplify 9 squared to be 81, still equals x plus 6 all over x. I need to get rid of the division of x, so I'm going to multiply by my x. I'm going to get 81x equal to x plus 6. I minus x to both sides, so I'm going to get 80x equals 6. I'm going to divide by 80. So x is going to equal 6 over 80, which is the same thing as 3 over 40, which also equals, I believe, 0.075. Again, make sure you're able to do these on your own. This was just a quick review over 8.7. So moving on to 8.8, we are looking at how are logarithms used to solve exponential equations. So please remember to think about that as we're going through our lesson. So logarithms are most often used when there is an exponent in the variable. So we really need to pay attention to when we get those. It's a lot of the times with a exponential itself, but we only try and solve them when there is an exponent in the variable. And we want to make sure we follow our process. Our process is very similar to 8.7, except your first process is we're going to isolate the base to the power. So remembering what the base is. So isolating the base to the power. Remember, base is this number with an exponent. That is your base to the power. You're then going to take the log or the natural log of both sides. You'll see that some of these are easier to deal with based off of specific problems. It does not matter which ones you take, but specifically with ln, if you have an exponential of an e, it might be easier to take the ln. You're then going to use the power rule to move the exponent. So this allows us to get the exponent down from the power, and then we can solve. So no need to check extraneous solutions on 8.8, but remember to check them for 8.7. I did not do that in bell work, but I promise you they work. Okay. So they're both positive. Okay. So now we're going to go on to examples, remembering our process. So remember to solve round to the nearest hundredth, so 2 decimals. And we want to begin by isolating the base to the power. As you can see, the base to the power here is 6x. So we're gonna divide by 2, okay? And we're gonna get 6x equals 14. As you can see, this is an exponential form. Here is the kicker. Do not transform the equation into a logarithmic form. Please do not transform into logarithmic form. There's a reason behind that. When you transform into logarithmic form, you're going to get a base of 6. You cannot plug that into your calculator. So that's why we're taking log to both sides, because then it allows us to have base 10. So now that we've done this, we're going to take log to both sides. So we're going to get log 6 to the x equals log 14. See, now we still have a base 10, and those are calculator capable. Now that we have x as an exponent, we're going to move it using our power rule. So we get x is log 6 equals log to the 14. And then we just need to get x by itself. So we're going to divide log to the 6 by log to the 14. So we're going to get log to the 14th divided by log to the 6th. So see, now that is very capable of being put in your calculator. So in your calculator, you're going to go log 14 in your parentheses divided by log 6. And that should get you to 1.47. Remember, to the hundredths place, okay? If you feel confident, please attempt to do number 2 on your own. At any time, if you feel confident, please make sure to pause before I can complete a problem, so that way you can match your answers to mine. Okay. So, number 2, we have e to the x minus 4 equals 16. So our first thing is we need to isolate the variable. So we're going to isolate by adding 4 to both sides. We're going to get e to the x equals 20. Well, we have isolated the variable, and our base here is e. So this is where, see how I did log up here because it's just easier to deal with? Well, this is e. What cancels out e? Natural log. So we're going to take the natural log to both sides. So we're going to get ln of e to the x equals ln of 20. If you can see what I'm about to do in the shorter term, please do that. But again, it's just as a reminder that x goes out in front, we get ln of e equals ln of 20. But ln and e cancel each other out since there is a base e there. So we're just left with x equals ln of 20. How nice is that? Well, since that's it, all we have to do is plug in our calculator, natural log of 20, which is right below that log button on your calculator, as a reminder. And you're going to get approximately 2.996. Well, we can't really round to the 100 spot, but it is extremely similar to 3. So 3 is okay in this situation. So we're going to get x equals 3. Remember, if you have any questions, please come and see me on Monday or email me at any time. Continuing. All right. So we have number 3, 11